So this is a temperature modeling concept. I'll show you some ways that you can calculate the temperature, the brightness value. Remember when the satellite image capture when the sensor capture the features on the planet Earth, the several bands are created. So especially in Lancet 8, Lancet 7, the band 6 or band 7 can be used as a thermal band to calculate the land surface temperature. So this is the instructions, or this is the formula equations that are followed in calculating the land surface temperature. So especially the 6th and 7th Lancet 7 thematic mapper. So these are the convention. You will find out that the first step is to convert the digital number to radians. So as the concept goes, when the satellite captures the images, captures the features on the ground or at surface, these features, they are represented as the digital numbers. Yeah, that is from electrical signal to binary digit, which is the digital numbers. So those digital numbers represents features or represents particular temperature differences on the earth surface. So in order to get a temperature, the first thing is to convert the digital number to a irradiance first using this equation here, this one. So this is where CV is the cell value, so radiance. So Cn here is the cell value digital number, G is the grain, it's the constant. Then B is the offset, this is the constant. When you get a metadata of the Lancet you are downloading or purchasing, you find out in that metadata G value or B value can be given. So you can utilize that to find out, or you can find out in the internet, just which says what is the gain value, what is the offset value of the Lancet 7, Lancet 8. If you are using Lancet 8, then this won't be a 6 and 7 band, it will be 10 and 11 band. Yeah, if you are using Lancet 8, but Lancet 7 is 6 and 7 band for the thermal or temperature calculations. The second formula is then you convert the radiance. This radiance here you have converted using this equation. Now the second approach is you convert this radiance to a brightness temperature. So you will use this equation here in the ERDAS model you are building. So T is the degrees in Kelvin. This one is the cell value as radians. The new raster has been generated. So this raster you are inputting here, which is radians. So this radians cell value created, those cell values represent the radians. Again, these are a constant you can find out. So the third approach is the convention of brightness temperature from degree Kelvins to a degree Celsius. So simply you already get your degree Kelvin here, but just to convert to the degree Celsius, it is here. This is the equations formula you can use. So you will find out that this is a practical that you have to do to understand what I have explained about how you can prepare a land surface temperature of a particular region, or city, or something like this. It is more helpful if you use the previous satellite and past satellite and compare the temperature differences, something like that. You can also do. So here you will find out that it is saying the model 5. You go to the model 5 and then launch the. So this is the model 5 here. I will submit, or maybe I have already given you. So you can use this data to at least calculate the land surface temperature. So this is the Lancet 7 ETM Plus. So that means we will use the band 6 and band 7 as a thermal band. So when we load, this is the one here. So after loading it, when we see the band combination, we select 7 band for all. Because we will be using the 7 band. So this one is like these images is a single image you are looking at it, but it has a lot of bands here. You will see it has already been mosaic, or it has already been layer stacked, and then there's more layers or images have been made up into a single image. But when you want to do some assessment for some places, towns, or cities, you have to download, but don't download the bulk. Just go for the band 7 only if you want to calculate the temperature, or band 6. But for Lancet 8, you must go for downloading band 7, band 11, or band 10. So for here, we go for band 7, layer 7. So we will use layer 7 for the calculation of temperature. So that's why we have to put it this way here, because we are only dealing with it has been layer stacked, so we are selecting layer 7. So that's the one here. That's the thermal band, you can see. So you will find out that the second approach is to click on the modular icon, which is somewhere here. You can see I'm using the ERDAS Imagine 8.5, the old version. But if you are using the new version, then everything is like 14 or 15. Or the approach follows the same process here that I'm explaining. So we have to click on the you will see model maker by following your instructions. So you will find out that this is the model builder here. This one here. So this is the one we are talking about. So in this new model window, we will open it. So we're gonna click the raster object, which is this one here. You can see when you click on toolbar. Let me go again. Both of them will appear. So this is the raster object here we are talking about. So just click here. That's we are creating the model now. So that's for the input raster that we will, for example, band 7 that we will input. This is the one that we have opened it. So now we will click on the this function tool here, which is this one. When you put a cursor here, you can see the name appearing here. So that's it. So we can click somewhere here, and then you will see. Now we will click on the model window for function in the model, and then from toolbar we will again click raster object, which is this one. So this will be as our output now. So this is the input, this is the function or equation or formula we will input to give us the output, which is here. So now we will get a link object tool, and then we will start link it up. Get it from here, and then again from here. Sorry, get it here, something like that. So just link it up, create a model here using this link tool here. So we click and drag, and then we draw. So this is the kind of pattern you will come across: the input, the function, and then the output. So in the we will click on file, and then we will save this model first. This is important, and then we will name it as a new model. So we go to a specified folder somewhere here. For mine, I can save it here. So I'm giving it a name, model, which is a new model. You can say new model, or whatever name you want to give. Click OK. That's it. You have already saved. And then you will find out that you want to go into a general calculation now, which is spectral value, which is a DN value of an image to radiance temperature. We will follow the first equation that I have introduced previously. So this is the first process that we will follow, which is a spectral. After creating a model, now we will go into first is to calculate the radiance temperature first. So now in the input box here, we will double click, and then we will input this lens set. Just double click here, double click, and then input the lens. So this is the data here. This one here you can see model 5, and then this is the one here. You input into this first, raster image input here. So that's it. Just go ahead and click OK. And then when we go to the this one here, now we will input this particular equation that we have discussed it previously. So we know that CV is the radians, and then G and B is the constant. So this one in the middle is the image that we will particular image that we have opened. So we will input that particular images. So now let's go ahead. This is the formula that which is 0.0. G is the constant we know. So that's the G we are entering it here. 0.05518. So times here. This is the times, and then you have to give a bracket, open bracket, and then you will double click on that length. So you see, these are the available inputs. So this is band 1, band 2, band 3, band 4, all are there. So we want to calculate the radians, so we have to go for band 7. So band 7 has been inputted. So give a close bracket. Be very careful with the formula you are putting in. And then you have to click on the plus sign, which is here, and then the constant, which is 1.2378, something like that. And then just go ahead and click OK. So the function to calculate the radians has already been inputted. So we just scroll down, and then you will see what is the next task here is to just click on this output here, click here, and then you go. So this is the area where you have to save, which is radians, or we can say dn values to radians. Click OK. Remember to select float single here. This is very important. Click here, and then you have to select this one here, float single. OK. Click OK, and that's it. So this instruction should come here, and this instructions to go up here. So there should be a changes here. Select the float single, and then you have to click OK. So that's it. Now we have to click execute here, which is this one here, and then our irradiance will be processed, executed, and then will be saved in the drive we have saved. That's it. So our irradiance has been already processed, executed, and then was saved. So we know the name. We gave the name DN radiance. So we know that, and then we know the folder we have saved, because we will bring that into again to calculate the temperature in Kelvin, which is the next formula. So we have to save this equation and then name it as equation 1 file, save as, and then we have to save it as equation 1, or you can say dn to radiance equation. So equation 1 is saved. Okay. So we have to close the model. We have already saved it. Then we go to the model builder again. Same thing we have to do here by clicking this thing here, this one here, here, and then here again. Same thing. You have to repeat as the previous you did. Get the arrows, and then you connect them. Click drag, let it go. Get it again. Click here, drag it, come down to this area, and then let it go. So that's it. Now we will use this equation here, and then we will start calculating temperature in uh, yeah, from radians. Calculate the brightness temperature in kelvins. Or we are going to calculate the brightness temperature. Let's find out. So here we have to click on our input will be radians. Remember that from our previous discussion. So we'll go here. This is the DN to radians that we have just executed before coming to here. So just go ahead and click OK, and then that's it. Just OK. So it has already been inputted. Now we will input this particular equation here, this one. So just double click on the function here, and then you go ahead, type in the standard, which is a 12.71 divided by the log. You look for log here, click down this here, and then maybe it is a exponential. So log is here. Just double click on that log. So remove this, and then you will input the constant, which is 666.09. This is Lancet 7 constant. Lancet 8 has its own constant. So you divide it by the irradiance that previously you have calculated, and then you have loaded here in this model. Then that's it. And then close bracket. So close bracket meaning I think there will be two open bracket. Can you see the formula? Two open bracket and then two close bracket. One is here and then one is after plus. That is you have to put one and then close bracket. One is constant. One is. So that's it. This is the equation that you should have inputted to convert or calculate the brightness temperature from the radiance that you have calculated. So okay, that's it. The function has been inputted. Now you can go ahead and specify your output folder. So now make sure to select the float double. Previously we have select float single. Now we will choose float double, which is double click here. Specify the folder that you want to save. So now we will give a name as radiance, radiance to brightness, or just say brightness. Okay, that's it. So this one here, click it down and then you select float double. Remember this. Okay, then that's it. It's done. Click OK. So you have to go ahead and then execute. So this one, your brightness temperature has been generated. The new raster layer has been created. So now you save this as equation 2 somewhere here at the same area that you are saving it. Just write equation 2. Okay, okay, and then okay. So that's it. And then you close the model and then we go to the next one again, which is now we will convert the temperature in Kelvin to degree Celsius. You know, whatever we have calculated just recently, and then we have named it as brightness. This is the brightness temperature in Kelvin. So now we have to get this brightness temperature in Kelvin to a temperature in degree Celsius. So that's it. We have to do the same thing. That is click the modeler here, get this one, click, get a function here, and then get this one, put it here. So the raster tool here, that's it. Double click here and then you have to input that radiance to brightness. That's it. And then okay, so your function should be look something like this one here. So double click on it and then you will see ABS and then bracket. So where is ABS? No, that's it. Just go to the other. Just go to the other here and then you will select ABS here. So ABS, double click on this and then it will appear here. So you can remove this and then just double click on this, which is the brightness, lens surface temperature, which is brightness that we have just calculated. Remember, don't refer to the names here. It is a typo, and also the names here. It is a typo. Just follow what I'm doing here. So that's the concept that you have to get it into practice. Huh? So this is the radiance to brightness that we have just calculated. Then we have to minus by 273. So you know what is 273. So that's it. And then you just click on OK. Check for parentheses. It's okay. So our equation formula has been set here. So just click on the output. So from output, you will just write a temperature. Temperature in degree. Yeah, degree. Temperature in degree Celsius, something like this. Okay, so let's find out what is the. So now we will temperature in degree Celsius, or we can just say uh, surface temperature or land surface temperature. Land land surface land surface temperature. Land surface land surface temperature. That's it. Okay. So remember, this is will now be unsigned 8-bit here. Just click on OK. That's it. We go ahead and execute a task here by clicking this one. So our land surface temperature has been generated. So OK. So we have to save our model as model 3 here, equation 3. Okay, that's it. So we have to close the model. So we have to check the results. So click load a new. We open the new viewer. Let's open the new viewer to confirm our results here, and then this is the land surface temperature that we have to open. So clicking this, and then you have to click on raster options and then put it to pseudo color, then okay. That's it. Fit to image. So that's the kind of temperature output results that you should have get. Okay, so this is the surface temperature that we have calculated. So hilly areas, they show the low temperature. To the township areas, they show a high temperature. So that's it. This is the result that you can open it in the ArcGIS, and then you can do a mapping. Let's find out. So after opening your ArcGIS, you can load the data you have calculated. I mean the temperature that you have generated from using ERDAS Imagine. So this is the area, this is the folder that I have saved. Maybe it is in a C drive here, practical here. Okay, so this is the land surface temperature that I have calculated using the ERDAS Imagine 8.5. So when you open this, just click on yes, it will build a pyramid. So this is the kind of images that you should have, final result that you should have come up with. So when you go to the table of content, properties, and then symbology, contains the color to something looking something like that, from green areas to the red areas, something like that. So this is the temperature in degree Celsius. Low is 8 degree, to the high is 44. So just some views or some ideas of the temperature differences from time to time. You can collect a lot of temporal images and calculate the temperatures using, if you are using Lancet 8, you have to use band 7. If you are using Lancet, if you are using Lancet 7 ETM Plus, you have to utilize the band 7 to calculate the temperature. If you are using the Lancet 8, then you have to utilize the band 10 or band 11 to calculate the temperature, one of them. So you can map this out and then you can present, or you can use this layer for the further analysis, incorporating with other layers. So that's it. I'll stop here. I'll give you a practical assignment. I will give you a practical exercise on this, so you can go ahead and do it. So you can simply produce a mapping here by clicking here. That's it. Insert grid, node arrows, whatever here, legends. You have to zoom in, zoom out, and then fit the taper, put it to landscape, portrait, whichever way you like, and then you can attach to your report you are writing or present to your client, or use it with the other layers to do further analysis and assessment.